example 4, give a rational function where the graph goes up on both sides of an asymptote. Also give one where it goes down on both sides. So far we've always seen our asymptotes where on one side it goes up and the other side it goes down, or maybe the other way, right? But is it possible to create something where it's going to go up on both sides, or going to go down on both sides? So let's look at our first one that we think. When we think rational function, we immediately think, oh, the basic thing that sort of makes up rational functions, 1 over x. This is the simplest form we can think of that really shows these ideas we're looking for. 1 over x winds up giving us a graph that is that gets very, very large, that gets to the right side, but goes down on the right, and then same thing, blows down. So the issue here with 1 over x, the issue is on one side, it's negative, right? On the left side, we were dividing by negative numbers, so we've got negative. On other side, it's positive. So that's why we go up and down. So that's what causes up and down effect. Well, down and up if we go negative to positive. But that's why we're seeing this split where we're going in two opposite ways. Because on one side of the vertical asymptote, we're dividing by a negative number. On the other side of the vertical asymptote, we're dividing by a positive number. They're both very small numbers, but that negative versus positive, that causes this incredible difference in whether you go to negative infinity or positive infinity. So what we want is we want positive on both sides if we're going to go up on both sides. So what could we create that would be similar to 1 over x, but always putting out positive things on the bottom? So let's keep it as 1 over. But what is always positive? Well, instead of dividing by x, let's divide by x squared, right? We can force it to always be positive. 1 over x squared, still a polynomial, so we're still a rational function. And if we draw that one in, we're going to see it behaving very similarly on the right side. It will wind up being here and here and here as we get to small numbers, right? As we get below 1, we're going to be getting to dividing by very small numbers, so it's going to blow out to infinity. And it will get crushed down to 0 as it goes to the right. On the left side, though, when we square a negative number, it becomes positive, so we're going to see a mirror image on the left side as well. So we're going to see it going up on both sides. If we want to get one that's going to go down on both sides, if we want it to be down on both sides, well, we see 1 over x squared. We just want it to go down, so let's make it as easy as just flipping it down. We flip it down by making everything negative, so negative 1 over x squared, and we'll see a graph that looks like this. We've managed to make it go down on both sides. So a simple way to make it go both sides go in the same direction is by having it be squared or having it be negative and then squared. Great. Not negative and then squared because that'd be positive, but a negative square because then it's a square number times a negative. Cool. All right. We'll see you at Educator.com later. Next time we'll talk about horizontal asymptotes and have an understanding of why it's getting crushed to 0 and see that it can in fact be crushed to values other than 0. Pretty interesting. Bye.